So we're here on the second weekend of the National Intelligent Robotics Prototyping Workshop that we're hosting here at Leeds. The idea behind this workshop was a bit unconventional. Rather than having people just sit around tables, brainstorm ideas and write things down on paper, the plan here was to go through the entire design process. The robots were designed on the first weekend, parts were ordered and 3D printed over the intervening week, and here we are on the first of 2 days trying to assemble, troubleshoot, test and show off these robotic systems. From what I've seen walking around the lab, I think things are going well. I think everyone has what they need, and I'm optimistic that by the end of tomorrow we'll have 4 largely functional robotic prototypes to show off.
This is an exoskeleton hand. It's going to be accommodating to those people who have atrophy or maybe a stroke, and they cannot move maybe their hands and the muscles actually and tendons around their hands. So what it's going to be doing, it's going to be kind of sitting on the hands of the people actually with this stroke, simply having them move their fingers and kind of doing the rehabilitation that's needed for them to be prepared or maybe recover actually from a stroke or something that has been stopped them from moving their fingers.
This is an off-the-shelf kit called the TurtleBot. It's a mobile platform, so it'll be able to navigate around the space using the Kinect sensor which you've got here. And we're combining that with this, which is a 3D printed arm, printed it here in Leeds. So we're going to combine the two. The purpose of the robot would be to potentially identify and bring us objects. So we'll be using some computer vision with a webcam on here to identify objects, and then hopefully the gripper will then pick it up and then it will be able to bring it to you using this.
This is our drone that we've just put together out of a kit of parts. At the moment it's pretty standard, so you fly it with a conventional remote controller. But what we're going to be doing with it shortly is we're going to be attaching this Raspberry Pi to it, which has got a nice little camera on it. And that's going to allow us to have it flying over an area and looking for things of interest. So the particular example we're using is we're going to try and find pests, and then we're going to send, so rats for example, and then we're going to send small little ground robots which don't have much intelligence in themselves, but they're being guided by this sort of overview platform to go and find the pests and then deal with them. But of course this is just one example of where you can be using sort of the drones to see over things and survey large areas and then task other assets which can go closer in and do more interesting close-up tasks.
The idea behind this project is that we're trying to make an entirely modular soft robotic system. So the heart of the robot is going to be these 4 currently incomplete flexible modules. So we're going to be actuating it using a pair of tiny little DC motors mounted in the segment itself. That means we'd be able to sort of extend it to any number, and it's much more scalable this way. And while there's still much work to be done, the basic idea is that it's tendon driven. So as the motor pulls in on the tendon, that's going to cause it to bend, and then, you know, with one on the other side, you can make it bend the other way. So ultimately, we are hoping to get as far as connecting these 4 legs to this little sort of central body, and we're hoping that it might walk.